Alright then, boys and girls, I've had a little change around in the room, moved some things, not sure if I like it. It's not important though, so we're going to move on. I've just voted as well. Good stuff, I like a bit of democracy. Yeah, so we've done indices, we've done surds. Now we're going to put them behind us and move on to looking at actual solid, good equations. And the main types of equations you look at in A-level are polynomials. Poly is a prefix meaning multi. You might know it from polyglot, speak many languages. Polygon, multiple-sided shape. Polyamorous. Anyway, so what we're going to do is we're going to go through different definitions of types of polynomial, and then we're going to look at some examples of doing some algebra with it. Nice and simple video. Then next time we'll look at quadratics and that stuff. Yeah? Sweet. Let's get this on. So first things first, what is a polynomial? A polynomial is an equation where it's a function of x, so x is your variable, and that x has a power on it, like x squared or x to the power 5. But we've got one condition, that the power on the x has to be a positive integer. No like x to the minus 1 or x to the power of a half. So let's get that down into a little sentence, then we'll look at the different kind of examples of polynomials that you need to do. Right, so I've just put that down into a little sentence. We've got equations of x to the power of n where n is a real number. Oh wait, that's wrong, isn't it? It's not what I said. So let's just correct that quickly. Now I said there has to be positive powers. So, remember that notation that we did a while back? It was actually the first videos. Z means integer, zinteger. Then you do a little plus on it, means it's got to be the positive powers. So let's talk about some actual examples. So, I've got too many pens, I've got some new ones. Let's say you've got your function. Let's do a column here, we're going to write functions down here. Now the most simple polynomial is one where there's not actually no x's. So we'll just call this a. Now a is a coefficient, and in this example, this is just a constant, it's just a number. Now for example, y equals 3, it's just a number. It's constant, it doesn't change. There's no variable to change that. So once we've got that, we've got something that comes next. Now you might know this from like earlier work that you may have done, linear equations. This is a linear equation. It's chairs in the way. Everything's in the way. See, I've put a chair here and now it's in the way. This is a binomial. Bi means like there's two, so that kind of makes sense, doesn't it? But you might recognize this as a linear equation in the form of like y equals mx plus c. And that's essentially what it is. So we could do an example like that. That's your linear equation. Sweet. So what comes next? Well, that's your non-linear equations. Your quadratics. Now these are really important. We'll spend a lot of time on these. And right now I want to point out why it's called a quadratic. And you might think that, well, it's got 2 here. Why is it a quadratic? So the reason is because if you think of a quadrangle, something which is square, that's got 4 sides. So quad is 4 sides of a square. That's a square there. So an example of that is something typical like x squared plus something. Like that. Bam. That's the stuff. What comes next? There's a few more, so I'm just going to smash these down and talk about them. So what we've got now, we've got, chair's definitely in the way. We've got a cubic. Now we've got x cubed plus some other quadratic bit. Then we've got what's called a quartic. Now we don't actually use the word quartic very much. After the third one, the cubic, you kind of just call them polynomials. And then you could keep going. You could have x to the power of 5 and so on and so on and so on. So let me just finish those examples. Okay. These are our examples of them. 3x cubed. See this bit in front of the x cubed? That's a 3. I'll talk about it in a second. And here we've got minus in front of the x to the power of 4, which means it's got what we call a negative coefficient. So that's the next thing that I want to mention. If you look at all of these numbers, well, not numbers, these letters that I put here, A, B, C, D, and all that lot, I've repeated the same ones, but they don't actually have any significance. What these are, they are called coefficients. Like this is called the coefficient of x because it's the number that would go in front of the x. These are just placeholders for numbers. This one, B is the coefficient of x here. A is the coefficient of x cubed here. D is the coefficient of x. E, D, C, B, A, in all these positions, the last position where there's no x after it, they're just the constants. So we can write that as a little thing. So A, B, C, D, and E, they're all real numbers. They're just the coefficients. So we could look at this one. Right over this side now, coefficient of x is 2. If we look down to our cubic, the coefficient of x cubed, that's a 3. The coefficient of x to the power of 4, what do you think it is there? Well, I'll tell you, it's minus 1. A lot of people forget that if it hasn't got an actual number in front of the x, then that means the coefficient is 1. Now these are really useful for defining these functions later on, graphing them, it's good stuff. So knowing that that's called the coefficient is really helpful at this stage. What comes next though is a word called degree. Now you would say that a binomial has degree 1 because the power on the x, the highest power on the x is 1. A quadratic has degree 2 because the highest power on any x is 2. Cubic is degree 3. I think you're realizing why, because the highest power on the x is 3, and so on. So let's put that in a little sentence before we move on. All right. So this is what I just said, but then I've done a little example. X to the power of 7 plus x to the power of 4. That's a polynomial. It's got integer powers on x, but this has degree 7 because that's the highest power on a 7. On an x. You get that? Now, incidentally, whilst we're here, this is a polynomial. If we have square root of x plus x squared, that is not a polynomial because it's not got an integer power on x. This is the same as writing to the power of a half, not an integer, so it's not a polynomial. Sweet, are we done? Well, not really. We know what a polynomial is, but we don't really know what we can do with polynomials at this stage. Ultimately, we'll graph them and we'll look at graphing like a quadratic and it goes ooh, or if it's got a negative x squared coefficient, it'll go ooh, like that. That was a good impression, right? But we want to just talk about addition. If you add two polynomials, all you simply do is you look at them and think, right, how many x cubes have we got on this one? How many x cubes have we got on this one? You add those two. You can't add x cubes to x squareds because that's like adding bananas to apples. You've just got a banana and an apple. Whereas if you've got two apples, you've got two apples. So let's get an example on the board and then go through that, and then we'll look at multiplication. Now, when I say addition, obviously I mean subtraction as well, so I'll correct that. I've done it. This is our question. We've got a quadratic here and it's added to a cubic. The degree of this one is 2, degree of that one is 3. When we add this, all we're going to do is go through it. Like here, we're going to add all the x squareds to all the x squareds there, all the x's to the x's here, all the constants to the constants here, and that cubic is going to add on to no cubics because there's no cubics. So obviously the answer is going to be add together our cubics. Easy. That's not so hard, is it? Our cubic, then we've got 2 lots of x squared, then we've got 3 lots of x because we had 2 here and then I've done that wrong. There wasn't any on the other side. So that's 2 and then 6 because we had 3 and 3. Whew. That's a piece of ease. Now what's a little bit harder though is multiplication. So we're going to look at multiplication but not division because we'll come back to that. This is our question now. We're doing multiplication. We're going to times this little tiny binomial by this quadratic here. Now the best method of doing this, I will always say this, is to do a little grid. Because every single one of these has to get times onto one of these. If you times in it just like one of them by a constant, like if you times in it by 3, then you get 3x squared plus 3x plus 9. That's easy. But now we're doing it with this binomial on the outside. You're going to times it, everything there by a 2x, and then you're going to times it all by 1. So watch this little grid I'm going to do. So I've made a little grid like this, and what I'm going to do is I'm going to go through and times each one. So 2x times x squared, 2x cubed. 2x times x, 2x squared. 2x times 3, 6x. 1 times x squared is x squared. 1 times x is x. 1 times 3 is 3. Now all you need to do here, there's space on the board, is to go through and add them all up. So 2x cubed, add that. We've got 2x squared there and an x squared there, so they're going to join together and make 3 lots of x squared. So all that we get here, and there you have it. 2x cubed plus 3x squared plus 7x plus 3. And that's the answer. Have we covered everything? I think so. Look at this down there. There we go. Get your eyes on that. That's the good stuff. As I said, we're going to come back to polynomials later on when we are looking at graphing them. And we're going to come back to each one of these in succession. We'll look at binomials as binomial expansions. We'll look at quadratics as a thing themselves. And then everything that comes after that will be just under the umbrella of polynomials. We'll do some really nice stuff like the factor theorem, which is, I think, the first theorem that you come across in A-level maths. And yeah, general graphing, we'll use this. A graphing calculator, which is allowed in A-level exams. Makes your life very easy. But I like graphs, so I would prefer everyone to actually know how to do a graph anyway. They're pretty easy. Right, that's it. See you next time.